Again, the easiest way to find the distance on the coordinate plane between points is to use the Pythagorean theorem. So what I'm going to do here is go ahead and draw in my right triangle. So we know that the distance between the points is going to be this diagonal line that connects them. So that's one side of my right triangle. I'm just going to draw in the other two sides. So there's my right angle. Remember, you must label your hypotenuse, the longest side across from the angle, is your c in the formula a squared plus b squared equals c squared. Make sure that you double check that you have labeled that correctly. Alright, so now we know that my legs of the right triangle, the a and the b, are my vertical and horizontal sides of my right triangle. Now, the part of this that we have to be really careful of in this problem is that the scale of the graph is not 1. Notice every single line, every grid line on my graph is counting by 5s, which means that if I were to count from this corner here and go, I would normally do like 1, 2, 3, which is fine and dandy, but on this graph that actually represents a distance of 15. Now there are two ways to do this problem. And I'm going to show you both. We're going to start out with using the actual length of this space. So that's 15. All right, and then this distance here would be 1, 2, 3, 4, but again it's 5, so it's actually 5, 10, 15, 20. All right, so then those are my A and my B. So I could have 15 squared plus 20 squared equals C squared. Then 15 squared is 15 times 15. I know that's 225. 20 squared is 20 times 20, which equals 400. And that's my c squared. Again, I just add my numbers on this side here. So I would have 400 plus 225 is 625. My last step is to undo the squaring on the c by square rooting. The square root of 625 equals 25 exactly. So my length of C in this particular diagram is 25. Now let's look at another way to do this. We started out knowing that on the grid I actually had 3 lines on my grid, like this distance was 3 little grid points. My distance on the other side was 4. Now if I did Pythagorean theorem, I'm going to redraw this triangle here just so that we can keep track of it. So if I use my lines on my grid, I could use 3 and 4 as my A and B. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. Again, we just add them. That would be 25. Undo the squaring by square rooting, and we get C equals 5. Now again, we have to remember our scale is 5, which means that we have to multiply each side by 5. So the actual length of this side is 3 times 5, 15. The actual length of the vertical side is 4 times 5, which is 20. And the actual length of my C is 5 times 5. So again, that would actually be 25. Either way, you get the same answer.